Well, welcome back once again, and today we're going to be writing our first smart contract for the NEAR protocol. So there's a couple of things that we actually need to set up first, which I forgot to mention when we were first setting up the environment. So let's go ahead, and the first thing is the Rust programming language. Using Rust up over here, we have the command to get it set up. So once you run this program, it should install both Rust C for Rust compile and Cargo. Cargo is kind of like a package manager for Rust packages, similar to NPM for Node.js. Get this installed. And the second thing that we will need to install is for trying out our smart contract outputs using RPC API, right? What we will need is Postman over here, and you can actually on Ubuntu, if you use the Ubuntu Software Center right here, you can simply look for it, so Postman, and you can then install it from the Software Center. I already have it installed, so it's all good for me. I don't need to do anything. If I run Postman now, this is what it looks like. So there are some other projects that I worked on. However, for this tutorial, we're only going to do near local tutorials right here. There are some of the RPC requests that I already saved. We're going to go over them once it's actually time to go over them, right? In the meantime, I'm going to go back to my terminal. Considering that you should have already installed Rust, you should have Rust C -- version. So you might have a newer version than I do right now, if you installed it recently and there was an update, and there should also be Cargo. Oops. Version, not a varsion. Okay, there we go. So I have a Cargo installed as well. Now, if you haven't used Rust in your life ever before, there's actually a channel on YouTube here by Bogdan. It's called Let's Get Rusty. And he has some really good tutorials to get you up and running with Rust. So there's a playlist here which goes pretty much through entire Rust laying book. So if you don't know anything about Rust, go ahead and study that part so that you are at least up to speed on what we're going to be doing using the Rust programming language. Because even though it is simpler than C, it is still a systems level programming language, and hence it's not nearly as simple as something like Python, for example. Simple meaning like easy to learn, you know. Now that we're done with this part, let's go back to our terminal. Actually, let's go first to our tutorial here. And we are right now in develop section contracts and then getting started. Over here we have a command to run our project installation. This will run both set up the contract folder along with Cargo and our front end using Node. However, in this tutorial, we're not actually going to do that. The way I'm going to do our tutorials is we're going to focus on backend first, and then we're going to do front end and then integration between the two. So we're not getting kind of jumping around from topic to topic and getting confused in any way, right? So we're going to do backend only with CLI first. And for that, we're going to install this whole thing, our smart contract, get it set up using just Rust Cargo. That's it. Okay, let's go ahead and do that. In the repository, I have contracts folder. So I'm going to change into that contracts folder. So I have nothing here. Now we can run Cargo init. So I'm going to run a help here. When we run Cargo init, we will need to specify that it's going to be a library and give it a name, right? So let's get that done. So Cargo, no, not Vargo, Cargo init -- lib, and then the name that I'm going to give it is hello contract. And just like that, we have hello contract. So if I cd into this contract, hello contract, and list what's in here, we have a cargo toml file, cargo lock, our source and target. Now I'm going to open Visual Studio Code in there. First, I'm actually going to close my previous version of Visual Studio Code. I'm going to open it now. So code dot. This is another prerequisite that I should have mentioned. Get yourself an IDE. Visual Studio Code is free. You can also install it using the software. So over here, when we do and installed, I think I have it here. Here, there's the Visual Studio Code, right? All right, so code dot to run the Visual Studio Code, and I'm inside our project here. So we have cargo toml, which we will need to update with some packages that we need in order to work on the NEAR protocol. And we have our lib.rs, which has nothing but a simple test right now. We will worry about that a bit later. So first things first, let's get our toml updated with what we need for this project. So I'm going to set version to 1.0.0. I think you can actually set whatever version you want, but I need to add this lib here because we are creating a library. I'm going to remove this, don't need it. For dependencies, we need some dependencies for NEAR SDK. For profile.release, we need also some parameters. I'm just going to copy paste them. This is all going to be submitted to the Git repository, and I'm going to save this. So this is it. Cargo toml is set up now. This is actually something that npx command does by default, but it also sets the front end as well. For now, we just want to work on the back end without any extra code or any extra commands that we might not understand yet. So let's just keep it simple for now. So here we go. This is our cargo toml. Now we need to go and run a few commands on our terminal now. Okay, so we need to change into the contract. Actually, this is our contract here already, and we need to rust up target and add this command right here. Rust up target add wasm32 unknown unknown. So that is done. Next, we can cargo build this whole thing using cargo build all target wasm32 unknown unknown release. And here we're going to get all the dependencies that we specified in the cargo toml file downloaded, and the lib file will be compiled. Okay, the lib file is compiled, although there's nothing there right now. So I'm going to go and copy the default hello contract that was provided by the NEAR. Where is it? Oh, here it is. So this is our basic contract. I'm just going to copy this whole thing and go over it. Go to librs, just erase all this and paste the default hello contract. All right. So over here, we're importing a few packages here for Borscht. This is the serialization deserialization package for storing, for serializing data into, you could say, an array of bytes and U8s. If you know what I'm talking about, U8 is unsigned 8-bit byte, so a byte basically. Over here, we're specifying a constant. Then we are deriving traits so that it could be serialized here. NEAR bindgen is the definition for a contract structure, as it specifies pretty much in this comment here. We need to define a default state of the contract here. So it's either through this default or through a new method that needs to be exposed. We don't have new method in this particular contract. We will go over that in the future. Implement the contract structure. So this is where we're defining the methods for what we do. So for example, getting greeting, we just get the self message clone. So clone, we actually copy the string and return it. And the this method here is to actually set string. So we are specifying the data, saving it into the self message. And because of these two because of this trait for Borscht, serialize, deserialize, and the contract structure definition, it is going to save this information on the blockchain for us. Okay, so once we assign self.message equals message, it will be saved to blockchain. By itself, the contract is going to do it. Okay. Then in the tests here, we are testing that these two methods do what they're supposed to do. So we're actually going to go more in depth about testing later on. For now, let's just compile this contract, run it, and actually install it onto our local blockchain. So I'm going to run the cargo build all target wasm again, like to rebuild this thing. And we have built it now. Our next step is to create an account on our local blockchain in order to store the file that we just compiled. Now, the file that we just compiled is located in target wasm32 release, and it is this this hello_contract wasm file right here. Now, I'm going to create an account using a CLI on our blockchain whose parent is going to be a.test.near. The account name is going to be hello.a.test.near. We created a.test.near in the previous tutorial, so let's go ahead and use that account to create a new account. I'm going to clear. I'm inside the NEND folder, so I will have access to the NEAR CLI. I'm going to do NEAR create account --help. So initial balance, we will actually need to set it. I'm not going to set it to 100 because if we check the amount that was stored in our a.test.near, right now I think it's less than 100. So if I do NEAR state a.test.near, yeah, we have only 94.99. So I'm going to transfer only about 10 tokens to the account. It is important to transfer tokens to the account because you do need to pay for storage of your contract there. So let's do this. NEAR create account hello.a.test.near. We need to specify the master account, which is going to be the super domain of this one. So if you consider this to be a subdomain of a.test.near, the domain is going to be a.test.near. Okay, so master account a.test.near. Master account is also the account which transfers the initial tokens to the account that's currently being created. I'm going to set initial balance to about, let's do 10. Yeah, let's do 10. And we're going to create this account now. Oh, something went wrong. Required argument master account. Oh, mistyped it. Master account. Let's run it. Very well. I created the account. Now, if I check my home directory near credentials localnet, I also got a hello.a.test.near JSON file here. So this is our public-private key pair for this account, into which we're going to be storing our smart contract. Let's go ahead and do that. Right now, we are going to deploy our smart contract here. To do a deployment, so the command looks something like this. So near deploy wasm file unknown and the release and then the whatever we have. However, in our case, it's not hello near, it's hello contract as far as I remember. Hello contract.wasm, yes. So let's change this to contract. Account ID hello.a.test.near. This is where we're going to be deploying this contract. And you need to have the public-private key pair to deploy a contract to the account. So let's run this code and see what happens. Okay, it looks like not enough balance to cover storage. Requires to have more near. Very well. So we're going to transfer more. We're going to do near send a.test.near hello.a.test.near, and I'm going to send 20 more tokens there. Now if I'm going to near status hello.a.test.near state. I always write status for some reason, like it's a state. Now we have 30, like 29.86. So let's try and deploy the contract again. Done. The contract is deployed now. Let's check the state of hello test near. It still shows that it reduced not by much. However, a lot of this near tokens now, they're staked for space storage. So there you won't be able to extract all these tokens unless you clear the space. Because about 18 or so tokens are being held by the storage. Now that we deployed our contract, we want to try and run it. To run this contract, we're going to call it using this address here. First, I'm going to open my Postman, and I'm going to submit an RPC call to view a state. So over here, when we create a new call, we create it has to be a post. So you set it here. This right here, this address is the address we got when we started our local system. So this is the RPC path to our local to retrieve data from the blockchain. Okay, and we do it in the form of JSON. So body right here, we have a raw JSON data which we're submitting here. So you can actually see how to run these RPC requests. Let me check over here in the RPC API tutorials on the near tutorial area. So we are running right now contracts, view contract state. So this is the one that we're doing. It looks something like this using JSON in our Postman. Now we need to define which contract we're calling. I'm actually going to clear the prefix. We're going to deal with this prefix later. And I'm going to call this hello. I'm going to save this, and we're going to send it off to the send point. We get a response with the block hash. There is no values right now, so there's nothing in the contract yet. Now, let's submit something into our contract. Let's call it using our CLI, right? So we're going to check how to do this using near call -- help, because using call is how we call our contract from the CLI. So over here we have contract name, method name. The method name is one of these two. So get greeting, set greeting. Contract is the name of our account. Near call hello.a.test.near method name set, what was the name of that thing? Set greeting. Okay. And now we're going to submit this JSON looking thing. So we have this message. This message, we call it message because over here this is called message, what we're submitting. And we're going to give it a value. The value of message is going to be hello there. And now I'm also going to specify an account ID. The account ID is required. This is the account ID that is going to be signing this request to the contract. So we have a few of them. We have a.test.near, b.test.near, and we also have this hello. We can even sign it with this one as well and take the money from the same contract and have it to call itself from the CLI. But for now, I'm going to use b.test.near, and call this contract and see what happens. Okay? And the transaction went through. Now let's check if something changed here. Let's send it. Over here we have something in our values now. So we have this gibberish here and then a bunch of gibberish here. Now this gibberish is actually base64 encoded string, and over here same thing. So let's decode it and see what it actually says. Let's go into this base64 decode encode website. So let's just grab this values and see what it actually means. So let's grab this and paste it and decode it. Well, in English it means state. Now let's see what the other one says. Oh, we have some gibberish here and hello there. Like, the reason why the gibberish is here is because we are encoding, like we're serializing this data first before we store it. When we query it back, we get it together with the serialized bits that are required to store the contract. Okay, so it is kind of in the raw state, you could say. That is why we have all these weird characters here before the actual hello there message, which we submitted to store in our smart contract. Now let's try and run the same thing from for example, an a.test.near account. Actually, let's try hello.a.test.near, and I'm going to say message will be something rude, like go away. And now it is signed. Now let's see what we have in the output here. So I'm going to send. It looks like it overwrote the data that we had before. So over here we will still have the thing saying state, but if we take this, a value right here, and decode it, we still have some gibberish here with the go away. Okay? So this smart contract, this hello smart contract, anyone who calls it just overwrites it. Yes, they pay the gas fee to overwrite it, but anyone can overwrite that section of the data that we have stored in our hello contract. In the more complex contracts and the future contracts that we're going to be developing, we're actually going to have to compartmentalize data for different users as to which data belongs to who, so to speak. But for now, this basic contract helps with understanding how the data in general being submitted to the NEAR protocol blockchain, right? So I hope this video was useful for you. You can experiment with it. There's a GitHub link in the description with this code. Don't forget to share, comment, like, subscribe, and I'll see you guys in the next tutorial where we're going to be doing a counter smart contract. We're going to be going through these basic smart contracts that are provided by the NEAR. And I'm hoping to go through them as soon as possible, maybe within this week, and so that we can move on to more interesting stuff, yeah? Okay, once again, have a good one, and see you next time. Bye-bye.